Hi everyone. In this video what we're going to do is find a quadratic function that satisfies three given points. So we're going to write our quadratic function in what they call standard form, which might not be so obvious what standard form is. So let me write that down. So standard form is y equals ax squared plus bx plus c. But we could also write f of x equals ax squared plus bx plus c. And what this information is, well, let's see what we can do with this information. What we're saying is that f of -8 is equal to -1. In other words, when x equals -8, y equals -1. Maybe I shouldn't even write it in that form, so maybe I won't do that. But I think that was totally fine, but I'll just not do that right now. But I'm going to write the standard form and put the y on the right-hand side. Okay, so going to the very first one, this is saying if I put in -8 as the input for x, then the output is -1. All right, so that's what this information tells us right there. All right, let me go on to the next one. If I put in, I'll go on to this one right here. If I put in -2 for x, the output is -7. Okay, so that's what that's telling us for that next. And the last point is if I put in 2, the output is 9. All right, these all simplify. Remember that if you have a negative and you square it, the negative in parentheses squared is a positive. That becomes 64a minus 8b plus c equals -1. 4a minus 2b plus c equals -7. 4a plus 2b plus c equals 9. I'm going to number these, although really maybe I don't need to do that at all, but I'm going to number these. All right, so what we have here is we have 3 unknowns, and we have 3 equations, and these are what they call linear equations because a, b, and c are all raised to the first power. There's other conditions, but it's not a times b or 1 over a or square root of a. It's of a form that they call linear form. And to solve linear equations, what we do is we try to eliminate variables. And what we can do is we can take 2 equations at a time. So I'm going to start with 1 and 2, but I want to just tell you that's probably more direct, maybe even easier to start with 2 and 3. But anyway, I'm going to do 1 and 2 first. What I mean 1 and 2, I'm going to take equations 1 and 2. But maybe anyway, you can look around to see which one you think might be the best to take out first. But in these problems, what I'm going to do is I'm going to eliminate the c, because what I can do is I could subtract one equation from the other. So before I like to just add. Adding the negative, same thing as subtracting. So I'm gonna multiply this second equation by -1. And why would I do that? Because my point is that I want to eliminate the c's. That's the easiest one to eliminate. So c plus -c is 0. So that's why I multiply by -1 and then I add them together. But you can just subtract them, but I a little bit formal there. So the thing is I have to, put a negative in front of it, take the opposite of each of these. So to do that right, of course. So 68, I could see myself multiplying the first one by -1, but not the second one or something. I have to reverse the signs on all of these. So c minus c is 0, then -1 plus 7 is 6. Okay, just to point out there, just to make this a little easier, I can divide through by 6. Divide by 6, so why not? Just to make it a little easier, I think I'll just do it in my head. 60 divided by 6 is 10. Then I have minus b when I divide by 6 is 1. And so what happens is I have one equation, except I think everybody's watching this saying, what are you doing here? I didn't write down a. Of course that's important. So I'll count up the mistakes. Hope that's all. Okay. So now what you can do is you can do a substitution method, but anyway, I'm not going to quite do that yet. What I'm going to do is, I'm going to come to that later. Now what I'm going to do is I'm going to look at the second and the third. So somehow we've already used 1 and 2. You somehow have to use the third equation. You could use 1 and 3 or 2 and 3. I'll just use 2 and 3. Okay, so I'm going to copy and paste those down. And again, I'm going to eliminate I'm going to eliminate C. And the way I do that is I'm going to multiply the first, I'm going to multiply by -1 on both sides of the second equation. So that is going to give, do I have to start a new line? Maybe not. Okay, let's see. 4a minus 2b plus c equals -7. -4a minus 2b minus c equals -9. And now when I add those, we see that there's cancellation. I should have maybe shown that cancel out above too. Maybe I'll go back. But there's 2 places it cancels. See, here we had these 2 canceling. Okay. So this makes -4b equals -16. So -4b equals -16 is another equation. Divide by -4. So b equals 4. So what happens is that when you do this this step, you get 2 equations that have a and b. This one only has b. So, but you do these steps, and when you eliminated c, and now you have equation with a and b. Another equation, well, with a and b, it's 0 times a, but still. So now we take these 2 and put them together. And what I'm going to do is I'm going to make like little snail tracks to show where I'm going with this. I like doing the snail tracks. So let me get that special dotted thing here. So I put those together, and I have, okay, 10a minus b equals 1. B is equal to 4, so certainly I can find a. Try to keep the handwriting nice. 10a, or at least try a little bit. So what I'm doing is I'm substituting. I put 4 in for b there. And so I get 10a equals 5. So a equals 5 over 10. And so a is equal to 1/2. So now I have yet one more. So we're getting there. And now I'm going to find c. How am I going to find c? I'm going to go to all the way to one of these 3 equations to find c. And I guess the first one, since that's 64a, might be a little more difficult to use, but otherwise the second or the third are all fine. I guess I'll use the third one. I mean, why not? I think that's the second or the third would both be good. And so what I do is I take this guy here, this gal, and I put in for a 1/2, and for b, remember b is 4. So I already, it's already highlighted. B is 4. I have 2 of I have a and b. I'm almost there. So b is 4 plus c equals 9. And so I have 2 plus 8 plus c equals 9. 10 plus c equals 9. C equals 9 minus 10. C equals -1. So that's my answer. So answer, I can just rewrite it. A equals 1/2. Oops, why did I do that? A equals 1/2. B equals 4. And C equals -1. Now, the thing is that we could say, well, how confident am I that that's correct. So, good question. What we can do is, well, actually, that's not even our answer. That's not even our answer, sorry. So let me just not say that. Okay, that's sort of our answer, but our answer really is y equals ax squared plus bx plus c. So we put in a is 1/2 x squared plus 4x minus 1. Okay, so I'm going to rewrite that as our answer. Okay, that was a little bit temporary insanity right there. And the thing is that also, I have to say, after all that work, I think I should try to finally express my final answer a little more neatly. I mean, why not? It's common, though, that I just feel like exiting now and getting out of this. But let's take some time to write it nicely. It's not that nice, but a little better. Okay. So the thing is that a good question is, well, hold on, this is important. How do I know I have it right? Well, what you can do is you can check your answer. And the way you check your answer is you go to your original equations and you plug in to see if it really works. So what I mean by that is I take these points here. So I take these points and then I just go through it and just double check that this is all going to work. So I have these points, and one of the things I can do, just that I was showing before, that I could write this as f of x equals 1/2 x squared plus 4x minus 1. Now, if I look at this, what I'm saying is f of negative 8 is equal to, well, let's see what it's equal to. The thing is this starts getting sort of tedious. So I could see that at this point you might want to just, I don't know what, turn off the video or whatever. But anyway, this is what you do. You check. And that's true then. If the first one worked, what was I doing? I was doing the first one. I put in negative 8 and I see I get negative 1. You don't have to use the f notation. You just use the y if you want. But anyway, then I go to f of negative 2. That's this one right here. And I want to see I get negative 7. So I have 1/2 and I put in negative 2. Square it, 4 times negative 2 minus 1. Let's see what I have. 1/2 times 4 minus 8 minus 1. 2 minus 8 minus 1, which is negative 6 minus 1, which is negative 7. Yes. Looks like things are coming along, or that it's correct. I mean, I have 2 of them. Is that enough? Yeah, maybe, but I better do the last one. I don't know, it isn't enough. I mean, it was sort of a joke. It's not enough. I have to do all if I really want to check. The thing is also interesting is you can sketch the graph and maybe even estimate this. That would be an interesting way to do this. Is you could sketch these points. You could plot these points. And then you can sort of just look at it and say, I think what the equation of the quadratic is this. That'd be sort of an interesting thing to try out. But to do that, I'd have to waste more time, switch over to graph paper. But let's just, once again, what if I mean, it's just way too much, or is it? But if I plotted these points, I think I could actually see a lot just by doing that. And I think I maybe could have answered the whole question that way if I were really careful. But the thing about that would be sort of assuming that I get answers that are integers or something, or the coefficients a, b, and c are all integers. But anyway, I'm just sort of curious about this. But the thing is, it's going to take up a little bit of room here. Oh no. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's, okay, again, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's 2, 9. I don't know why I did that first. It just somehow it caught my eye. Okay, negative 8, 1, negative 1. 1, 2, 3, 4, 5, 6, 7, 8, negative 1. I think I need to have smaller graph paper. Negative 2, negative 7. Yeah, negative 2, negative 7. That's this one. Let me get in darker. Okay. See, so what I can do now is well, I have this graphing program, so it's going to come out exact, actually. I think with this graphing program, it comes out exactly, because it exactly makes a quadratic and snaps to it. But you could check that this is this. Anyway, you could, well, is it actually? Anyway, there's a, oh well. Okay, that was like tons of stuff there. But I think I should just finish the video with the answer. Okay, thank you, bye.